1, 2, 3, 4, 5, 6, 7, 8,
Yes.
9, 10.
So the sample space would be as uh, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, that will be the
Cool.
sample space.
Cool.
Okay, I have placed that in a box now. Okay, mixed up thoroughly, and then one card is drawn randomly. One card is drawn randomly. Okay, if it is known that the number on the drawn card is more than 3, okay, what is the probability that it is an even? Okay, so let us try to understand this, what I was talking about. Now,
Okay.
if I call this as S, a sample space, which is an S, so we have been given 10 cards, which is numbered 1 to 10, and let's call an event A. A is an event. The number on the card drawn is even. Can you tell me which is even from 1 to 10?
2, 4, 6, 8,
2,
10.
4, 6, 8, and 10. Good. And another part of the event which can be represented as B. The number on the card drawn is greater than 3. Can you tell that?
4, 5, 6, 7, 8, 9, 10.
4, 5, 6, 7, 8, 9, and 10. These are the events. So we got two such events. One is with respect to even, and one which is the card which is drawn greater than 3. Now, now that we'll put that intersection of this A intersection B now. Okay, which is 4,
4 into 6.
4, 6, and 10. These are the elements. So these are the intersection, right? The common elements with respect to A and B. Now, now our question is like we have to find the probability of A, okay, and we have to find the probability of B, and we have to find the probability of A intersection B. Now, the question is, if it is known that the number of drawn card is more than 3, what is the probability that it is an even? So, this is with respect to the card which is greater than 3. This is the card drawn which is even. So our question is P of A given B. Our formula is P of A intersection B divided by P of B. Okay. Now, can you tell me what is P of A? One which is favoring. How many elements in A? P of
3.
P of A. Yeah.
5.
Yeah. 5. Right. 5 divided by
10.
5 divided by 10. Yeah. Okay. Can you tell me what is P of B? How many elements were there?
4, 5. 7 by 10.
7 by 10. Yeah. And P of A intersection B?
4 by 10.
4 by 10. Yes, 4 by 10. Yes. So we got P of A given B is 4 by 10 divided by 1 by. So this is 4 by 10.
Okay.
Okay.
Yes.
Suppose if I have a family has two children. Okay.
Hmm.
So what is the probability that both the children are boys, given that at least one of them is a boy? Okay. So,
Okay. Hmm.
two children, we consider B as a boy and G as a girl. Okay. Now, can you tell
Okay.
me the
Hmm.
sample space for this? What it
Yes.
can be?
VB,
EB, correct?
BG,
Yeah, BG, yes.
GB, and GG.
GB, yes, GBN. So this is the maximum uh, uh, sample space, right?
Yes. Hmm.
Now, let us put that in condition here. Let us put that as event E. So consider both the children are boys. So you will have BN.
BB.
Okay.
Hmm.
We'll take another event which has got at least one of the child is boy. So you can have BB, GB, and BG. Okay.
Okay. Hmm.
Okay. Now, our question is like, uh, what is the probability that both the children are boys, given that at least one of them is a boy? So you have to find the probability of E uh, F, which is P of E
E,
intersection
intersection of.
F divided by P of F. So, can you tell me what is P of E? First,
Uh,
even write this one E of E intersection F also. E intersection F. Can you tell me E intersection F?
uh, yes, it's BB.
Yes, PV. Yeah. Okay. Now let us
P of.
find what is P of E. P of E.
Yes, 2/8.
Yes, 2 by. Hmm? And
Hmm.
what is P of F?
4/8.
8, 8, no, not 8, no. You have only 4, no?
Oh, then it will be 1/4. Sorry.
Yeah, yeah. P of F, 3 by
3/4.
4, yes. And P of E intersection F,
1/4.
1 by 4. So let us substitute that. 1 by 4 divided by 3 by 4. P of uh, E given F is 1 by 4 by 3 by 4, which is equal to, which is the given answer. Okay, which we have found
Yes.
it.
Okay.
Which we have found it.
Hmm.
A die is thrown twice, and the sum of the numbers appearing is observed to be 6. So, what is the conditional probability that the number 4 has been appeared at least once? Okay, so here we'll call this uh, a sample space S. Okay, so X,
Okay. Hmm.
yeah, so it is twice, so it's 6 square, so it is 36. So N is
Hmm.
36.
Hmm.
Now let us call E is an event. Okay, so the number 4 appears at least once. So I'll tell you the first one, which is 4 and 1. Okay. Okay. Can you tell me the next one?
2/4.
2 4
The
or
4
4 2.
2.
4 2. Yeah, 2
Hmm.
4 is also correct. Let us keep 4 in the first place. Okay.
Hmm.
Yeah. And 4 3,
4 3.
4 4. Okay. And 4 5
4 6.
and 4 6. And 1 4, 2 4, 3 4. And again you cannot repeat that. Okay. Because it is same. 6. Okay. And
Yes.
another event which has got FB, the event that the number of the sum of the numbers appearing 6. So this should be 1 and 5. Okay, if you add it, you'll get 6. Again, 2
Yes.
and 4. Can you tell me another?
3 and 3. Oh,
Yeah,
3
3
and
and
3
3.
won't.
Yes, 3 and
Oh,
3.
okay, okay. 3 and 3. 4 and 2. So 1 and 5 and 5 and 1 aren't same?
Yes, yes, we can write that. You can write.
Okay, okay.
Okay.
So can we write 6 comma 0? No, it
0,
doesn't
0,
happen. Sorry,
no,
sorry,
it
sorry,
doesn't
sorry.
have.
Sorry, sorry.
Yeah. No problem. Now, um, let us find how many. Let us. Can you tell me the event that is E given F is P of E intersection F divided by P of. Okay.
Yes. It will be 2. 2.
What is P of
Will
E?
be 2 by 5. Will it be 2 by 5?
Yes, yes, it is 2 by. Yeah. So this you will get as 2 by 36, and this you will get 5 by 30. So it is 2 by. Solve it,
Okay.
right? If P of A is 7 by 13 and P of B is 9 by 13 and P of A intersection B is 4 by 13. Okay,
Hmm.
evaluate P of A given B. Can you tell me the formula?
Yes. P A intersection B
Yeah,
by P of B.
yeah. Can you calculate and tell me?
4 by 9.
Yeah. Now a die is thrown. Okay. If E is the event and
Hmm.
the number appearing is the multiple of 3, the number appearing is the multiple of 3, and F be the event, the number appearing is even. Okay. And we have to find whether E and F are even. Let us see. Okay. So a die is thrown, the sample space S will be 1, 2, 3, 4, 5, 6, right?
Yes.
A die is thrown. Now E,
Hmm.
if it is a multiple of 3. So can you tell me?
And 3 and 6.
3 and 6. Yes. And another event is the number appearing is even.
2, 4,
2,
6.
4, 6. And now E intersection F will be
Hmm. A intersection will be 6.
6. Yes. And P of E,
P of E will be 1 by 6.
yeah, 1 by 3. And P of F
1 by 2.
is 1 by 2. And P of E intersection F,
Mm, it will be 1 by 6.
1 by 6. So now the question is to find uh, whether E and F are independent. That is, here P of E intersection F is equal to P of E into P of F. So E and F are independent.
Okay.
See here, it is independent, right?
Yes.